We are celebrating World Space Week once again, and the theme year 2020 is Satellites Improve Life, aiming to educate the public about the benefits from satellite. Launch vehicle is the muscle power that put the satellite in the desired orbit for the intended purpose. Today, we have an exemplary scientist and eminent propulsion expert, Dr. V. Narayanan, Director Liquid Propulsion System Center, with us today to share his thoughts on rocketry and propulsion in ISRO, the past, present, and future.
Thank you, Rega. Before answering your questions, let me extend my heartiest greetings and wishes for all the viewers for World Space Week 2020. Let me also wish all best of health during these difficult pandemic times. I am sure humankind will overcome this crisis in a few months from now and regain the path of development and progress.
Thank you for the wishes, sir. For the understanding of the common man, why do we need these rockets and launch vehicles?
Well, this year, Space Week theme is Satellites Improve Life. Today, we cannot imagine a world without satellite. Satellite applications now are multifold, including communications, remote sensing, navigation, resource management, scientific studies, meteorology, disaster warning and mitigation, oceanography, cartography, and so on. For achieving all these, we need to realize the satellites and put them in the required orbits, say, for example, low Earth orbit for remote sensing spacecrafts, geostationary orbit for communication satellites. The role of a rocket or launch vehicle is to place the satellite into its intended orbit in a precise manner. The rocket enables the spacecraft to cross the Earth's atmosphere safely by overcoming the gravitational force of the Earth and also injects the satellite with a huge initial velocity around 27,000 to 37,000 km per hour so that the required orbit based on mission requirements can be achieved through further maneuvers. Today, as Indians, we all can be proud. We have developed number of sounding rockets and launch vehicles by which we are launching both our satellites and foreign satellites.
So we all know ISRO's humble beginning is through sounding rockets. Would you please elaborate on this?
Sounding rockets are intended for atmospheric measurements and for performing scientific experiments. As you are aware, Indian space program was started way back in 1962 by the father of Indian space program, Dr. Vikram A. Sarabhai. And ISRO was officially institutionalized on 15th August. The first sounding rocket, Nai Kapese, was launched by us in 1963 from Tumba. Following that, we indigenously developed our own sounding rocket, RH-75, and launched in 1967. It had a weight of 7 kg and achieved an altitude of 9.3 km. Subsequently, we have indigenously manufactured the French Centaur rockets, also developed variety of sounding rockets. The heaviest sounding rocket developed by us is RH-560 Mark III, which is a two-stage sounding rocket capable of carrying 100 kg payload and achieving an altitude of approximately 550 km, crossing the ionosphere. And every Indian can be proud. Today, to our credit, we have launched 3,497 sounding rockets from Indian soil. Even though sounding rockets are small rockets with limited applications, its development and launching has given us strong foundation for building and realizing heavier launch vehicles.
From sounding rockets, ISRO has come a long way with an array of launch vehicles. How do you assess this progress?
During the last 5 decades, we have developed 5 generations of launch vehicles. The first launch vehicle was the GSLV-3, for which the project director was none other than our former president, APJ Abdul Kalam. And we had the first successful launch of this rocket, placing 35 kg Rohini satellite in the orbit in July 1980. And that was a great day for India and for all of us. And we entered into the elite club of very few nations which had this capability of designing and developing satellites and placing them in the orbit by our own launch vehicle. From then onwards, we have moved in a big way. The second launch vehicle called the ASLV, which is a augmented version of the SLV-3, is subsequently developed. And the capability of the vehicle is 115 kg payload to the low Earth orbit. And these two vehicles, both SLV-3 and ASLV, we consider as experimental rockets. In fact, lot of technologies we developed through these two launch vehicles. And both the vehicles basically used only solid propulsion system. And from there, we had a quantum jump in the launch vehicle development. We had the PSLV. I think today PSLV is known to each and every Indian citizen, and we went for the huge development. It was a quantum jump, I will say, from ASLV to PSLV, and PSLV is capable of lifting something around 2,500 kg satellite for the LEO, or something around 1,500 kg satellite to the sun synchronous polar orbit, and which had a huge solid motor. And for the first time, we also developed and inducted two liquid propulsion systems in the PSLV. And we had the first successful launch of the PSLV in 1994. It was October 15th, 1994. And then onwards, till today, to our credit, we have launched 50 polar satellite launch vehicles, and which has placed multiple satellites in the orbit, and it has accomplished various missions. If you see the missions accomplished by PSLV, I think enormous. It has placed number of remote sensing satellites and number of foreign satellites, and we have accomplished the most prestigious Chandrayaan-1 mission through this launch vehicle. We have sent the Mars orbiter mission, and we have also accomplished 104 satellites in a single launch, which I think India is the first country which has done, and everyone can be proud of that achievement. And we had done a space recovery experiment through this PSLV, and 50 vehicles we have successfully completed. And the 51st vehicle, right now the preparation is going on in Sriharikota, and maybe next month we are targeting to launch. Now coming to the next vehicle. Next vehicle is the GSLV, Geosynchronous Satellite Launch Vehicle. And again a quantum jump from PSLV. And the capability of this vehicle is something around 2.5 ton to geotransfer orbit. Basically, it is meant for placing the communication satellites in the GTO. And there, the difference between PSLV and GSLV is, for the first time, we have to use a cryogenic propulsion system as the upper stage. And initially, we imported some of the hardware from other countries. And subsequently, we had mounted our own development program, and we developed the cryostage indigenously. Now, with the imported cryostage, we had the first successful GSLV launch in 2001. And with indigenous cryostage, we had the first successful launch in the year 2014. Till today, we have accomplished 13 launches, out of which 5 launches were with indigenous cryogenic stage. And this is the vehicle. You all may be knowing one of the great accomplishment of the ISRO. We have conceived, designed and placed a SAR satellite in the communication satellite in the orbit, and we have donated this to our neighbors. That was also accomplished by this vehicle, and it has placed couple of communication satellites in the orbit. The next vehicle is the GSLV Mark III vehicle, and the capability of the vehicle is 4,000 kg satellite it can place in the geotransfer orbit. Or if I put in the low Earth orbit capability, it can place something around 9,000 kg in the low Earth orbit. That is the capability of the vehicle. And we call this vehicle as a Bahubali rocket. And for this rocket, the entire new developments has to take place. We have developed new solid motor. It is called S200 solid motor. 2 numbers we are using in the rocket. And there is a core liquid stage. We call it as a L110 stage, where we use 110 tons of air storable liquid propellant, and this stage is powered by 2 Vikas engines, and we are having upper stage C-25 totally indigenously developed cryogenic stage. And we had the first experimental mission with the passive cryo stage in 2014, and this placed the crew atmospheric experiment module in the low Earth orbit, which was recovered back, which was first of its kind. We learned the recoverable technology through that mission. Subsequently, we successfully completed the C-25 stage development, and we had the successful mission, first GSLV Mark III D1 mission in 2017, utilizing the totally indigenously developed C-25 stage. And the mission was a grand successful in the maiden attempt. Subsequently, we had 2 more launches, and totally this vehicle has placed 2 communication satellites in the orbit. Also, the most prestigious Chandrayaan-2 in the required orbit. And today, if you see, totally in the launch vehicle development area, 75 launch vehicles we have launched. And total number of missions, including satellite missions, we have accomplished 189 missions, which includes 75 launch vehicles, 109 spacecrafts, and 5 experimental missions. And really, we have come in a long way in the launch vehicle development.
Sir, what are the different launch vehicle technologies involved in a launch vehicle, and what are the major infrastructures that you have developed?
Launch vehicle development is a multidisciplinary game. For the development of launch vehicle, all branches of engineering and science streams are involved. Now, if you see the launch vehicle development, first one has to design and configure the vehicle. And today, when I look back, we have mastered all the technologies associated with launch vehicles, which involves vehicle design, propulsion system design and development, both liquid, solid, and cryogenic propulsion systems, structures, aerothermal aspects, wind tunnel studies, control guidance aspects, inertial systems, equipment bay, the payload fairing. So all these technologies we have mastered today. Now, if you see the type of infrastructure what we have developed and put in place, we had the major infrastructures I can explain you. Major infrastructures are the solid propellant plants for producing solid motors, and plants for producing liquid and cryogenic propellants, and indigenous materials development, and manufacturing of rocket systems, pyro system development, and huge test facilities, and facilities for carrying out aerothermal studies, and facilities for preparing, for assembling and preparing the launch vehicle, and launch complex facilities for servicing the propellant in the launch vehicle. Also, we have built 2 world-class launch pads. So these are all some of the technologies and infrastructure what we have developed for the launch vehicle.
Propulsion is integral with launch vehicle technology, and you are heading the leading propulsion center of ISRO. Would you please throw some light on the launch vehicle propulsion that has happened over the 5 decades?
Propulsion systems are power-intensive devices employed for powering the launch vehicles to lift off, cross the atmosphere, and inject the spacecrafts in the required orbit. With the current state of aerospace engineering, chemical propulsions are the only means employed for powering the launch vehicles. ISRO started the propulsion system development, rather the solid propulsion system development in the early 1960s. In fact, we had developed the first indigenous propellant, Mirinol, and we successfully fired on 21st February 1969. From that onwards, we have developed variety of propellant and solid motors. To our credit, we have developed so many solid motors. Now, if you see the smallest solid motor used for the US in the SLV 4th stage, which had a propellant loading of 262 kg. From that, we have come a long way, and today we are having a solid motor for Mark III. What we have developed is with 207 tons of propellant loading, and which is third largest in the world. And now if you see the type of thrust what it generates, in fact in the Mark III vehicle, we are using two solid motors, and both put together gives a peak thrust of something around 1200 tons of thrust it generates. And if you see the propellant consumption rate, the average consumption rate is 4000 kg per second. Now I should give you a comparison how the number is so big. You take our car, take for example our Maruti car. You know what is the propellant consumption per second? It is 3.5 gram per second. Against that, the Mark III vehicle, when it is lifting off, two solid motor, we are consuming 4000 kg per second. So that is the type of flow rate what we are using. Then you can understand what a powerful motor it is. Now, in addition to that, we have also developed lot of small motors for variety of applications, including one of the motor what we have used for the moon impact probe. The mass of the propellant is less than a kg. So, to our credit, lot of motors we have developed in the solid system. Now, coming to the liquid system, in fact, the development activity started in the liquid propulsion area in 1969. And initially, for the first two launch vehicles, whatever I told, SLV and ASLV, we have developed and delivered control power plants using the liquid propulsion systems. And when it came to PSLV, we have developed and delivered two main propulsion systems for the second stage of PSLV and the fourth stage of PSLV. For the second stage of PSLV, we have developed a system using the French Viking engine technology, and we call that engine as the Vigas engine, which is capable of developing almost 80-ton thrust. Then coming to the Mark II vehicle, the Viking engine, in fact, 5 numbers of Viking engine we are using. 4 engines are strap-ons and 1 engine in the second stage we use. And Mark III, again, as I told, it is having the core stage is a liquid stage, having 110 tons of liquid propellant and powered by 2 Vigas engines. Till today, we have we have used almost 120 numbers of Vigas engines in our 75 vehicles. Now, coming to the next system, the cryogenic propulsion system. Cryogenic propulsion system is basically using cryogenic propellants, and till today we have developed 2 propulsion systems, one for GSLV Mark III vehicle and another one for GSLV Mark II vehicle. And these are all the 2 systems we have developed, and India is the 6th country which is having this propulsion system.
You are the key person behind the success of indigenous cryogenic engine, and you made every Indian proud through the glorious victory of GSLV and GSLV Mark III. Would you please elaborate on this cryogenic propulsion a little more?
Yeah, this is really a subject which is very close to my heart. Actually, if you take the cryogenic propulsion system, basically the cryogenic propulsion system uses liquid hydrogen and liquid oxygen as the propellant combination. And these two are at extremely low temperature. Low temperature means it is hydrogen is at minus 253 degrees centigrade and oxygen is at minus 183 degrees centigrade. And the cryogenic propulsion system, the major advantage is among the chemical propulsion system, this gives the highest performance. We call it as the performance index called specific impulse. The number is almost 70% higher than the solid propulsion system. Now, in view of this higher performance, this is essentially required for placing higher payloads in the orbit. Now, when you come to our Mark II vehicle, and the upper stage is a cryogenic stage. In fact, if you take because of the extremely low temperature of the propellant, and hydrogen is having a characteristic, it is a explosive characteristic is there, and it is also having very low density. Due to these 3 reasons, the development is very, very complex. And ignition without explosion is again a big challenge. Yes. And all the materials cannot be employed for cryo application. Only very few materials can be employed. So we have to develop materials And the storing this propellant, which is minus 253 degrees centigrade, is very challenging task. So we have to develop insulations, and lot of development work has to take place. So in view of this type of complexities, elsewhere also people have taken lot of time. So considering these complexities and long lead time required for the development, initially what we thought was, if possible, we'll try to get this technology from other spacefaring nations. And in fact, I want to tell, we also entered into an agreement with elsewhere USSR. But unfortunately, due to geopolitical reasons, this technology transfer could not take place. Of course, we got a couple of hardware from them. Then in 1995, we started our own development of cryogenic stage, which is identical to this Russian version of the cryogenic stage. And the engine, it is having an engine which has to develop 7.5 ton thrust, and the total propellant loading what we conceived was 12.8 ton propellant loading. And in fact, it has taken for us almost 18 years to come to a logical conclusion and succeed. And we have faced a lot of problems. In fact, I will say a couple of major failures we have faced, including the engine failure in the first flight. But then, in the rocketry system, we should not be shy away with this type of failures. And failures are the stepping stones for success. So we have learned, and a long way we have crossed. And it was in 2014, finally we delivered the cryogenic stage for the GSLV, indigenous cryogenic upper stage for the GSLV Mark II flight. And the project director of that flight was none other than our present chairman, Dr. K. Sivan. And I also was given a great responsibility. I was the group director of the engine development, and I was also the associate vehicle director for the cryogenic stage of that vehicle. And finally, we had a major success. Rather, the engine ignited successfully and worked perfectly well, and injected the GSAT-14 spacecraft in the required orbit. And we became the 6th country in the world to succeed in the cryogenic propulsion technology, and I think every Indians were so happy on that day. Now coming to the Mark III vehicle, I told the capability of Mark III vehicle is almost 2 times compared to the Mark II vehicle. Now when it is 2 times, it is having upper stage, again it is a cryogenic stage, and that stage, the thrust of the engine is almost 3 times of Mark II vehicle. It is a 20-ton engine, and the propellant loading is 28 ton, and it is a totally indigenous effort. And I was the project director of that project. And finally, we had a lot of development activities, and I am happy to inform the viewers that we did lot of experimentation, and all the experimentation, in fact 200 experiments we carried out, except one setback, everything was successful. Finally, we went for the flight. It was in 2017, we had the first GSLV Mark III D1 flight, equipped with our own indigenous cryogenic stage, that is a C25 cryogenic stage, and it perfectly worked and injected the satellite in the required orbit. And this was a maiden attempt, we made the success. And it was a great day, rather, I will put it that way. Thereby, even though we started the cryogenic propulsion system development much later in the country, and the advanced countries, rather the other countries, other spacefaring nations, they were not ready to part this technology with India. Today, I will say we are so lucky, and because of our systematic effort and teamwork, today we are having 2 propulsion system, cryogenic propulsion system, indigenously developed, and we are the 6th country which is having this guarded and complex and high performance propulsion system in the world.
Sir, you gave a very good picture about the launch vehicles and the related technologies. Definitely it will be interesting if you explain a bit about satellite program too.
In similar lines of launch vehicle development, our satellite technology has also emerged over the years. And we had the humble beginning of our satellite program in 1975. We realized and successfully developed the first Aryabhatta experimental spacecraft and launched. And we had initial satellites, the first remote sensing satellite Bhaskara, first communication satellite Apple, and today if you see, we are having a host of satellites. We have variety of satellites. for navigation, communication, earth observation, oceanography, and strategic applications and scientific missions. We have developed a lot of satellites. To our credit, till today we have launched 109 satellites. If you see the satellite technology, say when you talk about the remote sensing satellite, the first Bhaskara satellite, we had a camera with 1 kilometer resolution. From that, we have gradually improved ourselves, and today we are having in the Carto 3, for example, our camera resolution is 0.28 meter, which is really, I will say it is a world class. Rather, we are in the top in the world in this area. And now if you see the satellite mass, how it has grown, the SLV-3, I told, 1980 we had the successful SLV-3 launch. And you know what was the satellite, Rohini satellite mass? It was weighing only 35 kg. From that, today if you see, the heaviest satellite what we have developed and realized is the GSAT-11, which is a 6,000 class satellite, 6,000 kg satellite, and which is successfully launched. That means from 35 kg, we have moved to 6,000 kg level. And in terms of payload, for example, the resolution of the camera, 1 kilometer to 0.28 meter. And again, another one of the parameter people used to talk about satellite, that power capacity. Today, our capability of power handling is something around 20 kilowatt. And one more thing is, it is not only so many satellites we have developed and realized, and we have also launched till today 319 satellites of 33 countries. And including one of the communication satellites, we have launched by our GSLV Mars vehicle, and rather we have helped the SAARC countries to use that satellite. Rather, we have donated to our neighbors. So today, Indian space program is helping not only Indians. I will say that the entire world it is helping one way or other. And if you take the scientific missions, we have successfully gone to Moon twice, and we have gone to Mars once. And like that, in the satellite area also, I will say we have come in a long way. And in fact, today also the government has approved almost 47 spacecraft for the common man.
Okay, sir. Now, in what all ways these Indian satellites help the common man?
Actually, if you ask me this question, I have to speak so much. But however, what I will do is I will tell only the major applications. Major application is, say, one is the telecommunication and television broadcasting. If you take, I think when we were young, 25 years back, you know the country, what was the condition of the telecommunication. In fact, my village, I am from a village, there was no telephone connections. And today, most of the people are having mobile connectivity and telephone connection. And today, to our credit, we are having something around 300 transponders in the orbit. But even then, I want to tell one thing. We have made really a revolution in this area, telecommunication and television broadcasting and DTH, we have made a revolution. But I would like to tell 1 or 2 points. If you take today, India, almost 56,000 villages are not having telecommunication. So it is our responsibility to bridge this gap also. Another area is telemedicine and teleeducation. Now, we have developed this concept and we have already launched the satellites and it is put for application. You know, today, the pandemic situation of COVID-19, this is finding more application because our entire education system has gone to digital system. You all know it. So it is having more application. And again, we are having remote areas like Northeast. From there, and people can consult the experts in the medical field in cities. So this is another area. Now coming to Earth observation resource management, I think we have done wonder, I will tell you. All resources we are monitoring. In fact, one example I can give you, the crop production forecasting. You know, this is very, very important for policy planners to understand what is going to be the production and how much we have to export, how much we have to import. To decide all these things, this is mandatory things. And today, we are monitoring almost 15 crops. And ISRO is having clear plan to go for 30 crops in another 7 to 10 years. Now, another area is one example I will tell you, potential fishery zone. You know, we are having long coastal line and lot of people are going for fishing. And we, through the satellite images, we identify the potential fishery zones and we inform the fisherman. You know, what is the type of profit we get per year? It is something around 34,000 crore per year is the profit only through this application, then you can understand. And we have also gone in a long way in disaster warning and management. There were days when there is a disaster, flood or anything happens, we lose a lot of our colleagues, lot of our brothers. But today, the satellite system is coming in handy and we are having wonderful job. We inform the people well in advance and we also contribute in the management of the disaster situations. And another area is, say today 8 navigation satellites are in the orbit. And with that, we can do lot of service and we are doing lot of service. One application I will tell you, in the country we are having today 8,800 trains. Now 2,400 trains already we have put automatic train tracking system. And in the coming years, we are going to implement for the entire trains. And this navigation is going to really do lot of service. I have told only one example. Again, satellite data is also used for the strategic applications. Now, we have got a portal, a citizen portal called Buon, in which the entire data, most of the data I will put, we have the maps rather, which is coming from the satellite, we have loaded and it is available for the public use. What is the type of utility? Per day, 10 million hits per day is the type of thing what is used by the common man from the different villages, different panchayat across the country. Now another thing is, if you see the space program, what it is doing, if I put a nutshell, it ensures safety and security of the persons, people, citizens, also enhancing the quality of life. Now coming to the future, if you talk, the renewable energy utilization is one of the area we are going to do a great contribution. And NAVIC messaging receiver for fishermen. In fact, I want to tell, in Kerala, we served this as a experimental phases for 30 fishermen. And when they carried this, the message came in Malayalam itself. And they were informed about the locations and about the potential fishery zone. And the people went with that apps, with that equipment, and they could find lot of fishes. And this is another area, really, the apps we are going to contribute. And if you see, last 45 years, from the 1975 to till today, we have launched 109 spacecrafts in orbit. And next 7 to 8 years, I expect similar number of launches we are going to do, and which is going to serve the common man of this country in a big way.
That's really wonderful, sir. Now, the Chandrayaan and Mangalyaan are the two remarkable achievements of ISRO in the recent past. Would you please dwell more on that?
Yes, we had 2 Chandrayaan missions and 1 Mars orbiter mission. The Chandrayaan 1 was launched by the PSLV vehicle. In fact, I want to tell it was a most prestigious mission. And we had a moon impact probe, and which using that mission, it landed on the moon impact probe, impacted on the moon and put our tricolor on the moon. And another important achievement through that mission is, the entire world was trying to understand whether the moon is having any water molecule. And it is we Indians, through this Chandrayaan-1 mission, we first time found water molecules on the moon. And every Indian can be proud of this major achievement. Now coming to the Mars orbiter mission, it is another prestigious mission. The going to the red planet is not that easy. From Earth, almost 6 million kilometers we have to travel, and a lot of people have achieved this. But the important thing is, India is the first country achieved this successful mission in the first attempt. That is the major achievement of India. And again, this is a low-cost mission. In fact, our Honorable Prime Minister used to make a statement, the money what we have spent is nothing but the travel, whatever you have done. The per kilometer, whatever you have spent for the Mars orbiter mission is less than our auto charge. This is what he used to say. So basically, Mars orbiter mission is a low-cost mission and achieved the success in the first attempt and by our country.
Okay, sir.
And coming to the Chandrayaan-2, it is yet another very, very prestigious mission. And in fact, we were supposed to, we planned the mission to land on the South Pole. Rather, we are the first country, we made that attempt to land. Now, we had the successful launch by the Mars 3 vehicle. And in fact, the Chandrayaan-2 mission is a 3-in-1 satellite. There is a orbiter unit, and there is a lander and rover unit. In fact, we successfully place the orbiter in the orbit. It is supposed to have a lifetime of 1 year, but because of our meticulous planning and the proper and over performance of the Mark III vehicle, I am happy to inform the viewers that against the design life of 1 year, the orbiter is going to work for 7.5 years, which is having 8 important payloads. One is called a orbiter high resolution camera. You know what is the resolution of this camera? Something around 0.3 meter, which is the best as on date in the world, and which is sending so much information, and we are going to use. Now the second portion, we are having the lander, and the lander is supposed to land on the moon. In fact, we had made a very, very meticulous planning of the mission, and the initial mission went very well. When it reached almost close to 2.1 kilometer of the moon, unfortunately, we had a hard landing and we also lost the communication from the satellite. But I will say it is a very, very minor issue. But if you see the overall mission in terms of Chandrayaan-2, including the launch and placing the orbiter in the required orbit, and the way orbiter is sending the data, and the way we have achieved that most of the technologies of the lander system, except the soft landing, we could achieve very, very, very good thing. But however, nothing is equal to 100%. Now we are going to plan one more mission called Chandrayaan-3. Maybe next year we are going to attempt the soft landing.
So satellite propulsion is vital for these missions like Chandrayaan and interplanetary missions. And of course, LPSC has proved its mettle in that field. Now, what are the development activities on anvil?
LPSC is developing propulsion systems for spacecraft. The propulsion systems of spacecrafts are little different from launch vehicle propulsion system. Launch vehicle propulsion systems are highly power intensive and operate for very short time, whereas spacecraft propulsion systems are less in thrust and it has to operate for long duration. While in the initial phase of deployment of the spacecraft, the propulsion system is required for imparting the required velocity for orbit raising. When I say orbit raising, you know, generally a communication satellite will be placed in an elliptical orbit. And to take it to the required orbit, the satellite propulsion system adds velocity and it does its job, bringing the satellite to the required orbit. It also does the function of inclination correction and station acquisition function. Now, throughout the life of the satellite, this spacecraft, this propulsion system, it does also work almost 10 to 15 years, and it does the function of attitude correction and station acquisition. In fact, when the propellant loaded in the propulsion system gets depleted, most of the time the satellites are decommissioned. Rather, the life of the satellite mainly dictated by the propellant quantity and the propulsion system. And to our credit, in LPSC, we have developed varieties of thrusters for this purpose. We have developed both monopropellant thrusters and bipropellant thrusters, starting from 1 Newton thrust level to 800 Newton thrust. 800 Newton thruster, what we used in the Chandrayaan-2 mission. And let me explain the function of a spacecraft propulsion with a simple example of taking us the Chandrayaan-2 mission. You know, our Mark III vehicle injected the Chandrayaan-2 in an elliptical orbit of 170 km by 45,000 km. From the Earth, it injected. And from that, the moon is something around, from the Earth, around 4 lakh km. So, this function was done from 45,000 km taking to that 4 lakh km moon orbit was done by firing the propulsion system on board of the orbiter unit. We had a propulsion system exclusively for that. This engine was, we call it as a liquid approach motor, which was an indigenously developed motor. And almost number of times we have operated this motor, and we have taken from 45,000 km to 4 lakh km. And it was also used for perfectly placing the Chandrayaan-2 in moon's orbit. This is the function of the orbiter propulsion system. Now, second function is, as I told, the orbiter is already going to work for 7.5 years. The entire 7.5 years, this propulsion system is going to do a key function of maintaining its orientation, maintaining the, doing the station keeping. This function it is going to do. Now, second thing, we had a lander system. Lander system, you know, the lander was separated from the orbiter. When it was separated and it was in the moon orbit, it was rotating with a speed of something around 6,000 kilometers per hour. At the speed it was rotating. Now from that, we have to bring and soft land on the moon, and over a period of 16 minutes time, the 6,000 kilometers per hour speed has to be, with a braking, it has to be reduced to near zero. So we have developed a propulsion system with 800 Newton throttleable engines. In fact, 5 engines were used. This has to give braking the velocity. 6,000 kilometers per hour, you can imagine that velocity. From that, it has to gradually reduce the velocity. The engines used to operate in the opposite direction, and we have to bring the velocity near to zero. So this is another function what it has to do. So like that, the spacecraft propulsion, the functions are different and the requirements are different. I am very happy to say that LPSC has done a wonderful job in developing all necessary thrusters required for meeting the spacecraft propulsion. Now one more point I want to tell. Say I told the life of the spacecraft is basically dictated by the quantity of propellant what is stored on board. Now currently we are developing a electric propulsion system. The electric propulsion system, basically the electricity is used and which is accelerating the ionized gases. So in that process, if you see the propulsion system performance, the performance will be almost 4 to 5 times that of the chemical propulsion system. With this electrical propulsion system, when it is deployed, you know, the performance is almost 3 to 4 times higher. So the propellant quantity requirement comes down. When the propellant quantity requirements come down, it can be converted as a useful payload. That means a 4-ton class satellite, if you see the useful payload will be something around 700-800 kg. Now this can be almost 2.5 times higher if you use electric propulsion instead of the chemical propulsion. So that is the development work which is already undergoing, and last few years we have worked, and maybe in the couple of years we are going to succeed in that area.
Sir, India is embarking on its prestigious human space mission Gaganyaan, and definitely it is a topic of great interest to public. Would you please say a few words about that?
Yeah, the Gaganyaan program is announced by our Honorable Prime Minister Modi ji, and which is intended for sending 3 Indians to space. And you know, sending Indians to space is very easier, and we have to also return them back safely. And before 15th August 2022, when we are going to celebrate our 75th Independence Day. In fact, towards this program, we have to develop a number of technologies, and across the ISRO centers and industries and academia, this work is going in with full vigor. And in fact, before sending the man and bringing them safe, we are planning 2 unmanned missions. These are all planned maybe next year, and we shall be using our GSLV Mars 3 for this purpose. Now, you know, this Mars 3 vehicle is originally a expendable launch vehicle. Now, when it is going to be deployed or employed for the human, for sending human, this entire vehicle system has to be man-rated. And only a human-rated or a man-rated vehicle can be used for the purpose. Now, what we are doing is we are revisiting all the systems. Let it be propulsion, avionics, guidance control, and the equipment bay, everything we are revisiting to ensure the required margin is available. And wherever required, we also incorporate redundancies. Take avionics system, and we are going to incorporate the necessary redundancy. Take the pyro system. There also already we work is on. And all the propulsion system and structures, everything, it has to undergo a lot of tests. Then only it will be cleared for this type of mission. So one is the man rating of this vehicle. That is one of the important activity. Next thing is, in addition to that, you know, to send the man, lot of other technology has to be developed. For example, the crew module in which the human beings are going to be there, and that crew module development, and there is a service module which has to be developed. Then in case of any problem, the crew has to escape. For that, there is a crew escape system is required. Then the space suit for the astronauts, and environmental control and life support system for them, and the entire mission planning. That is a very, very complex job. And the astronaut health management system. All these developments are concurrently going on across the ISRO centers. And another important activity also I want to tell, when we are sending the unmanned flight, we are also going to put a half-humanoid robot. And this development also, IASU, which is one of the ISRO unit in Trivandrum, they have taken up. In fact, they have come in a long way. They are in the final phase of development. So, really, with the type of background and knowledge what we are having, I don't have any doubt we are going to have 100% perfect success in the first attempt, not only in sending the man to space and also in bringing them safely back to Earth.
That's good, sir. Anyway, what are the future missions and advanced technologies ISRO is aiming for?
See, apart from the Gaganyaan program, we have a host of scientific missions lined up, including, as I told, the Chandrayaan 3, then Aditya L1 mission, Mars Orbiter Mission 2, SpaceX, and the orbiter we are thinking of sending to Venus and ExoWorld. And all of this involves meticulous mission planning and development of cutting-edge technologies. In the launch vehicle area, if you see, ISRO has taken up numerous developments, including a development of a 200-ton thrust semi-cryo engine and a stage with 120-ton propellant loading. Basically, the semi-cryo engine uses liquid oxygen and rocket-grade kerosene, which is a very low-cost fuel. And this development is going on rather in LPSC itself. And along with this development, we have also taken up the enhancing the capability of the C-25 cryogenic stage with higher propellant loading and increased thrust level. With these two developments getting completed, when we integrate this, the Mark 3 present payload capability is 4 ton to GTO. This will simply become 50% more. That means 4 ton to 6 ton to GTO. That means, the cost of the cost for per launch will come down to that level. And next, another important development is taking place in ISRO centers, mainly in VSSC, a small satellite launch vehicle. It is a new vehicle development which is having a capability of 500 kg in LEO. This development is almost in the final phase and we are going to have the launch somewhere in the first quarter of next year. And why this development we have taken up is, if you see the international space market, there are plenty of scope, plenty of market available for the small and micro satellites. So we also want to get our own share. And this vehicle, within 15 days from the time of getting the order, we can place the spacecraft. So that is the type of configuration what we have conceived, and the development is almost completed. We'll have the launch next year. Now, we are also planning to develop heavy lift launch vehicles. When I say heavy lift launch vehicle, our Mark 3 capability, low Earth orbit capability is something around 10 ton. Now this we want to take it to a level of 20 tons. So towards that, we are already studying what type of propulsion systems are required. In fact, we are planning to cluster semi-cryogenic engines, 4 numbers. And when you cluster four engines together, we'll have a thrust of something around 800 tons. And we are going to develop a new semi-cryo stage with 400 ton propellant loading. And then the cryo stage, the upper stage also, we want to develop a new upper stage and host of other launch vehicle technologies we are planning to develop for this purpose. And another important thing is, when you talk about the low cost access to space, you would have heard, or rather seen, the viewers would have seen the recovery of the stages by USA. Yeah. And in fact, we have also initiated the study and recovery of reusable, the stages. This area we have initiated the studies. Another important area where we are embarking on the development is air breathing propulsion. In fact, when you take the propulsion system, we need oxidizer and fuel. But in the atmospheric air, you are having lot of oxidizer. So here in the air breathing propulsion, we only carry the fuel and we use the atmospheric fuel air as the oxidizer. And already we are developing an engine which we are going to demonstrate very shortly for a period of 250 seconds we are going to fire. And another thing is the LOX methane propulsion system. The methane is a low cost fuel, plenty available in not only here, in other planets also. So this engine development also the R&D activities initiated. In fact, we have made a proto engine. We are thinking of doing experiment with that engine. Now, for performance improvements of launch vehicle, number of enabling technologies and developments are taking place across the centers. Now, couple of things I want to highlight. One is hybrid propulsion, tri-propellant engine, then liquid air cycle engine system, and miniaturization of the avionics system and electronics packages. This is one area a lot of work is going on. And when it comes to the materials development, indigenization of material, now some of the materials we are importing, now the indigenization also a lot of activity we have taken up. And another important thing is the manufacturing, additive manufacturing is one area we are concentrating. Then silicon anode based lithium ion cells and range of sensors and transducers for health monitoring of various parameters also we are in the process of development.
So what is the role of this industries and academia in space program?
See, today the Indian space program is a national program. Actually, the industrial partners and academia is contributing in a big way. Rather, the ISRO has enabled them to contribute in a big way. And I want to tell, for example, today our launch vehicle budget, almost 80% of the launch vehicle budget is invested in the industry. And 60% of the spacecraft budget is invested in the industry. Rather, the Indian industries are contributing in a very big way. I can tell you the numbers, approximately 500 Indian industries throughout the country are contributing for the both launch vehicle, spacecraft and application area. Now, academia also, the future generation, the students are there and teaching faculties are there. In fact, academia is contributing in a big way for our program. Almost 110 academic institutions are contributing in our space program today. In fact, almost 500 MOUs we have signed with different academic institutions, and in the coming years, this is going to grow further. Now, again, government has opened up the space sector for private industries. So, slowly, in the coming years, the industry participation is further going to grow for the development of Indian space program and for the benefit of common man.
Sir, it will be nice if you share some of the most exciting moment in the journey in ISRO as a propulsion expert.
See, in ISRO, every day is exciting since we are dealing with the cutting edge technologies. I will share maybe one or two experience. You know that cryogenic technology, only other than India, only 5 countries are having this propulsion technology. And initially, as I told, we approached other countries for technology transfer. We could not succeed. And then we started our own development in 1995. And we took almost 19 years to get the success. And it was in 2014 January, we had the GSLV D5 flight equipped with our own indigenous cryogenic upper stage, which we have toiled for the development over a period of 19 years. And when the vehicle director and the ROD announced that the cryo engine has successfully ignited and it is performing extremely well. And finally, after almost 12 minutes, when the declaration came that it has successfully injected the spacecraft GSAT-14 in the required orbit, really it was so much excitement, not only to me, the entire team of ISRO, not only propulsion community, entire ISRO team was so much excited, and I was not the exception. I was also having so much excitement. Now, second thing, when you take the Mark III vehicle, a lot of new developments has taken place, but my experience, my area was the development of the C-25 cryogenic stage, which was a totally different stage from the CUS stage. And I was the project director of the stage, and we went through the development process. In fact, out of 200 ground experiments, 199 experiments were successful. Then we went for the flight program. When we went for the flight program, it was, I remember it was in January, it was in 2017. and the GSLV D1 flight equipped with our indigenous cryo stage, C25 stage, was successful in the maiden attempt. And I think as a person who led the project team, and it was really, I had so much excitement, and it was basically teamwork, not it is an individual, more than 5,000, 6,000 people are involved in that game, and it was really so much excitement. I think if you talk about this excitement, I can talk hundreds of that, but due to limited time, I am stopping with these two experiences.
Okay, sir, please tell us what is your message to the youngsters who aspire to work in this launch vehicle area?
Well, sky is not the limit for professionals aspiring to work in the area of launch vehicle and space technology as a whole. Launch vehicle is a highly interdisciplinary area which needs knowledge in all branches of science and engineering. One has to dream big, work hard on your aspirations. There is no shortcut to hard work and resilience in this area. And one should have got willpower to overcome failure and go ahead. Coming are the days, as I told, we are going to have a number of interplanetary missions, human spaceflight program, and for taking human to the space and bringing them safely, development of heavy lift launch vehicle. And ISRO is always a learning organization. And in this profession, we cannot stop our learning at any stage. And here, every activity we do is viewed with equal and great respect. And the Indian space activities, it is basically a teamwork. Teamwork with win-win situation has to be strictly followed. Before I conclude, let me quote a statement from Dr. APJ Abdul Kalam's autobiography, The Wings of Fire. I quote, "Total commitment is the pivotal quality for those who wants to reach the top of their profession," unquote. Let me guarantee a very exciting career for all youngsters aspiring to join this area.
So you have explained the complex rocket technology and other space aspects in a very effective way. And thank you for sparing your valuable time for us. Thank you very much, sir.
Thank you, viewers, and thank you, Rekha.
Thank you, sir.